I will let Aiden present who he is as part of his talk, but I'm going to pass it over to Ezekiel just to give a little bit more of an introduction about the user group and also our sponsors. So I'm going to pass it over to you, Ezekiel.
Excellent. Thank you very much, Arlan. Well, welcome everyone. Thanks for joining today. We appreciate your taking your time out of your personal time to join us to learn more about the Azure world. So today we are very excited to have Aiden again present the advanced edition of the infrastructure as code with Terraform. So my name is Ezekiel Calabi, and I'm founder and technical lead with VNextIQ. So I've been with the Azure group for about 5 years now. So, kind of keeping the group alive, hosting the meetups, organizing, finding the speakers. So very exciting to see the evolution of the Azure space, and very glad to see people like returning or new members trying to learn about this world, because it seems that we are just getting started, but there is so much more to come, and so there's a very exciting few years ahead for the IT industry, especially for Azure and Microsoft. So thanks again, and I'll pass on the floor to you, Aiden, to say hello and introduce yourself.
Sure. Yep. My name is Aiden Ermy. I work for Microsoft as a cloud solution architect, specializing in more Azure. Prior to joining Microsoft, I've worked with a lot of different Microsoft partners within the Toronto area. So some of you may know me from that perspective, or also work with different clients and customers. But I'll have my contact information at the end of my deck too for everyone to connect with me.
Thanks, Aiden. I'm just going to pass it over to the next slide and let Ezekiel talk about our great sponsors here.
Excellent. Yeah, so we'll a quick thank you to our sponsors, VNextIQ and Microsoft, for being behind the Azure group and continuing to provide support to us.
Thank you. And any words on staying at home and staying safe?
Yeah, so I mean, we want to recognize that we've been carrying over this slide for the last 3 months or so. We want to recognize the difficult times that are facing right now. So we encourage you to stay positive, to stay home as much as possible, to respect your local guidelines, especially since that we have people joining from different parts of the world. So we understand that different countries, different provinces have various guidelines. So we encourage you to respect your local guidelines, and yeah, so this shall pass, and will remain positive. Thank you very much, Arlan.
Thank you, Ezekiel. So I'm just going to go through the last set of slides quickly because we want to get started with this great presentation here. So just for you to continue your learning process beyond this attending this session, we have some slides here about different options for learning, including actually almost all of these are free. So the one you should always start with, it's free, it's excellent quality, is learn.microsoft.com. There's great content there, not just on Azure, but also on other Microsoft technologies, and it's a great place to start. They also have a learning path for Azure, so there's a way to learn from basically almost zero up to more advanced levels, so please check it out. It's a great place to learn without any cost, because I know for some people right now, finances are difficult and tight, so this is a great way, a high quality, and it's free. One thing that people realize that very quickly is that if you're going to learn about Azure or any cloud or any technology, you need to be hands-on. No matter how great a speaker Aiden is and how great the content, you need some time to actually work with it, explore it, make mistakes, redo it, and that's a really way to learn by being hands-on. So you could get a free Azure trial subscription. You get about $200 US or $260 Canadian. It doesn't require a credit card. And it allows you to get a membership, depending on how much activities you perform and how many services you spin up, about at least a good month or longer easily. Plenty of time to learn and apply some of the courses that you're learning about through some of the free learning. And of course, if you shut down your services or size them accordingly, you could probably stretch it out further than a month as well. The other part, other great area to learn from is edX.com. It has lots of different courses, not just on Azure, but also on the other cloud environments, on programming and other technologies, and also other areas that do not involve technology at all. So a great place to learn. And we are now past 1,608 members as of about half an hour ago. So we're now on our way to 2,000 members. That's our next goal, our next milestone for the Azure group. So 2,000 members, we'll have to celebrate once we get there. And also don't forget to follow us on LinkedIn. Here is the reference link for that. And you'll find that the links for the content will be posted there. So for anyone joining us just now or may not have seen the chat window, this session is being recorded. It'll be made available through the LinkedIn page that you're looking at right now, that link for LinkedIn for the Azure group, as well as through the Meetup page. So both the video as well as the PowerPoint deck as a PDF will be provided. And it's a great way to go through the content maybe at a more slower pace, or maybe spend more time on certain areas and learn at your own pace. So at this point, I'm going to pass it over to Aidan and let you take it from there. Thank you.
Cool. Thanks, Arlen. Thanks, Ezekiel. Let me start by sharing my screen. And if you can just give me a confirmation that you can see the presentation.
Yes, I can see it. Looks great.
See it.
Perfect. Okay, and just a quick FYI for everyone, because I'm operating on a single screen this evening, I can't see the chat. So if you do have a question, use like the raise your hand feature or put it into the chat, and Arlen or Ezekiel will interrupt me appropriately to answer that question, or even also feel free to come off mute if it's a bit more complicated of a question to type in the chat. That way we can kind of answer it in line with what we're talking about, but we'll also have some time at the end for everyone for a Q&A if there's any additional questions. Okay, so if tonight we're going to talk about infrastructure as code using Terraform specifically. If you're familiar with my other presentations, this is the advanced edition. This is full-on DevOps stuff. The original presentation was the beginner edition, where we talked about the language and the constructs of the language and the bits and pieces, understanding how those kind of come together, getting a feel for that, comparing it to ARM in this context. The intermediate version, we talked about more intermediate concepts with Terraform, like modules and loops and those types of elements, and how we use those to start to develop a more, let's call it realistic or more real world template approach and coding approach in using Terraform in production. And then today we're going to touch on how we're going to take that sample code that we had in the intermediate one, which we'll show in a moment. That's the hub and spoke topology as that starting kind of foundation for the environment. We're going to take that and we're going to deploy that through a pipeline. So we're going to actually compare Azure DevOps and the DevOps pipelines. We're going to compare GitHub and GitHub Actions, and also Terraform Cloud as well. So we're going to deploy the same environment, the same code, but in these three different DevOps tool sets to get a feel for, you know, how hard it is, how easy it is, you know, some of the nuances with those tool sets, and what you can't do, some of the lacking or gaps in that as well that I discovered in going through that, just to kind of put some context around there. So if you've been in my other presentations, there's not too much overlap or repeat from what we did in the intermediate or the beginner one. There is a few slides that are the same, just for context, in case people weren't able to attend one of the other sessions. But today, this is what we're talking about: deploying Terraform using all three of these DevOps tools, and then resources and certification, which are similar to what we've added in the other presentations as well. So here's one of those repeat slides real quick. I won't spend too much time on the repeat slides because we have the recordings for the other ones, but just in a nutshell, we want to stress or emphasize to everyone that Microsoft is completely invested, excuse me, completely invested in Terraform. You know, we love Terraform. It's not us versus them kind of context. We both have teams that are working on the same Terraform resource providers and technologies to make that work really well in Azure. We want it to be on par, the same way we have ARM for Azure templating deployments. We want to make it at that same level. So that's what we're striving to do. We're constantly releasing updates to the Azure RM provider. That is actually Microsoft's responsibility as part of this contribution and this relationship that we have with HashiCorp. So the latest release for the ARM provider is 2.18, which was just released, I believe, last Friday. And in that release alone, there were 23 new features added, like new data sources, new resources that we could create and manage through Terraform. There were 27 enhancements to the provider itself. There were 6 bug fixes. And for reference on like, well, how often do we really actually update and contribute to this? Is it like the old days where you have to wait every quarter, semi-annually, that type of thing? Not at all. In June alone, we actually released 4 times, basically once a week, we are pushing out updates to this provider as we go through that. Terraform, well, actually HashiCorp, but Terraform has a public module registry that Microsoft actually directly contributes to. So even though it's hosted on the HashiCorp site, on the Terraform site, that you can leverage these public modules in your code, Microsoft is actually writing these and authoring and publishing them for public consumption and use back to the community there. Excuse me. So a quick mention of the roadmap, because this kind of comes up in conversation a lot. Like, when is this coming, or this feature isn't present, or this is broken, and so forth. If you go to our public GitHub repo for the Azure provider for Terraform, you can publicly access this. There's milestones for the different versions of the provider and what will be included in that release. So we see version 19, which is literally due tomorrow. And we see, okay, it's got maybe some dependency or some documentation enhancements. We've got new data sources coming. We've got maybe a new property, so enhancements to existing resources, for example. This is public. You can go in and kind of see what we're working on, when something will come in case it's maybe something you're looking for, and that type of thing to kind of help guide your use of Terraform on Azure, and where, if there's a gap, where we're striving to kind of close that gap as quickly as possible. One other thing I want to quickly highlight, again, this was part of the intermediate conversation that we had last week, but version 13 of Terraform, which is still in beta, is out in beta at least, we get some really good features. One of the ones that I'm really excited about is that depends on, specifically for modules. That's going to make it so much nicer to kind of stitch pieces together, stitch the blocks together, and be able to deploy in a more seamless way. Really excited to see that. And the variable validation, really interesting enhancement that we have here, where we can put conditions around the variables so that when the input is received, if we're authoring these modules either for public use or like a private module registry internal to our organization or for a customer, we're able to wrap validation around that to ensure the input is not only a string in this kind of context, but also matches patterns or needs specific to what it is. So really good enhancements that we can start to add a little bit more kind of guardrails, I guess, or a better end-to-end or user experience when using our modules and executing against that. So really nice to see that starting to come out from version 13. So this is the reference code that we're using today in our example. Similar to our intermediate version of our presentation, we're deploying a hub and spoke network topology, right? So kind of a standard approach where there's a central shared services space where stuff's being deployed, like say domain controllers, the primary monitoring systems, and so forth. And then we're connecting those systems in the networking perspective to these spoke virtual networks, VNets. So maybe we have one for prod, maybe we have one for non-prod or development or QA, and we're like stitching those together. So that's the context that we're taking our example code, but now we're running it and executing this through a pipeline and understanding how do you work with variables in these pipeline tools, how do you work with the output, what are those gaps, and so forth. So we know if we're going to choose one of those tools to help customers or ourselves to build out a full end-to-end DevOps process around Terraform on Azure, knowing kind of some of those gotchas and what we can and can't do, at least today with that. So the first one we're going to talk about is Azure DevOps itself. So ADO for short. I have a GitHub repo with the sample code that we're using for this. For each of these examples, basically it's pretty much the same code in each one with minor modifications based on, okay, GitHub Actions has something unique or Terraform Cloud has something unique that you need to put in or modify. But basically it's the same code. But then I know some people have asked for that from the previous session. So I've put that together for everyone there. And that'll be shared out afterwards as well. One thing I want to share with everyone, which was mentioned previously in our intermediate edition, was that we can now use Terraform to actually create our DevOps, Azure DevOps stuff. So creating our Azure DevOps project, doing our build definitions, linking it up to our repositories, making our variable groups and variables around that and executing against that. So not only are we authoring infrastructure as code to deploy our environment, we can now author our DevOps process, if you will, through Terraform as well, and link it up to an applicable YAML file, which is yet another code file, but that's the pipeline as code effectively. So some really awesome stuff. This is just in version 001 that was released, so it's very, very new, not fully kind of baked, so to speak. There's still obviously gaps and stuff that they're working on, but it's really exciting to see not only we're driving towards infrastructure as code, but full end-to-end management of execution of that through something defined in Terraform. So something really cool to take a look at. So now I want to just talk about just briefly, what is the configuration I used in Azure DevOps specifically for this type of an example. First and foremost, I want to call out that I used the Azure DevOps repo and not a separate GitHub repository for this. Why? Well, because of course, yeah, well, we can use GitHub and that's great, but I was going for this full-on Azure DevOps encapsulated experience, especially because I was going to also do this repeat action, the same process, but purely in GitHub with GitHub Actions. I wanted a complete separation from that aspect to avoid some confusion. I have it integrated with Azure Key Vault for our variable groups to be able to link it to sensitive information like our service principal credentials, like that secret password for it to log into Azure to do the execution and that type of thing. We'll see that in the pipeline library. And I also created multiple pipelines as part of this process. One for the deployments, so deploying our hub, our spoke, and then our peering connectivity. And then one for cleanup, which is just for demo purposes, so I can revert everything back and be able to do the demo again. Now we're going to dive into the actual code of what it looks like from an Azure DevOps perspective. So I'm going to pause right here just for a moment before we dive into this to see if there's any questions up until this point.
Thanks, Aidan. There's no questions on the chat window, so unless anyone wants to come off the mute and ask any questions, we should be good to go when you're ready.
Okay, yep, fair enough. No problem. Feel free to interrupt if and when there is. So our first example is the code, the YAML code that defines our actual pipeline trigger. So we're saying we're gonna trigger this off of a branch, specifically the master branch. So you can use your like feature branches for development and testing and all that good stuff. And then we're only going to focus on the master branch. And then we're specifically going to watch certain files within there. So notice in my example here that I'm watching a text file because I was using that for individual testing of each piece separately before I stitched those together in an end-to-end workflow. So I was just trying to trigger each piece separately to validate that component was working. So that's not obviously needed in a production space, but the other examples below that I have commented out there, I still have for reference. Notice that I can tell it to watch the master branch, but specifically, I'm going to watch the code files in my hub module or in my hub deploy module. So it's not limited to a specific directory, right? If you're only targeting the deployment trigger module versus the source code of the module itself, you can kind of add bits and pieces so that if one or the other is updated of these files, that we're able to then automatically trigger the execution of this pipeline. Next, we're going to look at the variables that we are passing into this pipeline. The first piece that we have highlighted is the variable group, and we're going to show this in the portal in a moment, but this is our Terraform build variables. This is the element that we actually have hooked up to Azure Key Vault to be able to pull in that sensitive data, like the credentials we're going to use for a virtual machine that we're going to deploy, or the SPN credentials that we need to log in to connect to Azure to do the deployment and so forth. Those sensitive pieces of information. We're linking it to a pre-existing group that we've already created. We also have inline other variables that we're passing through, like subscription, our tenant ID, app ID, the storage account where we want to store our state file and all those bits and pieces, right? So you can even, if you feel that those are still sensitive pieces of information, or your customer feels that those are sensitive informations and you don't want to put that in the code of the pipeline itself, then you can put that in, say, a key vault to be able to abstract that information as well. So lots of flexibility here, but this is kind of the kind of starting point in building that pipeline code itself. Now here comes the meat of what we're going to execute. And this is a little hard to read because I had to make it small enough to fit actually all on one slide. So my apologies, but what I'm going to walk you through some of this. First and foremost is the steps are obviously what's going to be executed in this environment while we're triggering this pipeline. The first thing we need to do is install Terraform because it's going to execute this in a container or against a virtual machine. Notice that I have Terraform version highlighted. This is important because from an Azure DevOps perspective, if you do not define the version of Terraform, the default version at the last time I've tested this was 12.3. And that throws you off a little bit. It's like, why would it be .3 when we're already up to version 12.28? And I think it has to do with number ordering because 3 comes after 2, but it's not like it's double digits, not 0.3, it's 3. So it thinks it's higher or newer than .28. In this, or 2.6 in this example. So keep that in mind when you're building the pipeline. It is still a best practice. If you've attended the intermediate session, if you remember, it's best practice to pin your version types for your Terraform code and your modules and all that and the providers and so forth. You're going to want to do the same thing and align that in the pipeline code as well, so that that version of Terraform pinning in the pipeline is also the same version that you're pinning in your actual Terraform code, just for consistency there. Next, we have the login script that logs into Azure in this case to have that SPN so that we have the authorization to deploy these resources. This is where we're passing in those variables. So not only the inline variables with the app ID like we showed on the previous slide here, but also we're passing in from that group, variable group, into this SPN password parameter as well. So that's where it's obtaining the password itself among the inline variables that we've already defined in the rest of the template for the pipeline. Now the script piece is a bit bigger because by default, Terraform init is fine on its own, but we need to be able to store the state file if this is going to be a continual run and not like a one-off thing, right? So we're passing through into the pipeline the variables for that resource group, the storage account name, the key, the access key. This is also coming from the variables group that's linked into our key vault, and then also the state file. So what are we actually going to call the state file respective of what we're trying to deploy? The other piece is when we actually execute the plan among all the other bits and pieces that we have there, the piece that's highlighted is the variable file and the plan file. So by default, those two properties are not a part of the Terraform plan execution string that's provided by default. So if you want to use a custom TF-vars file specific to like region or whatever you're trying to execute against, like prod or non-prod, you're going to have to add that into the Terraform plan command line and pass that through in that case. Same thing with the plan file coming out. If you want to execute on, have an artifact effectively of the plan file, you need to use the -out to produce that. And then we see in the Terraform apply, now we're saying apply the plan that was actually generated. So those are some pieces that you actually have to add in that are not there by default. That might throw you off when you're just getting started in this type of flow. Here comes the good stuff. The pipeline chaining. So this was a little confusing, I'll be honest, when I was first trying to understand how to get this to work. But notice how we still have the trigger there and it's set to none. Because when I was trying this without having trigger, like that whole block gone and deleted, it wouldn't work the way I would expect it to work. So you still have to have trigger none, and then we're saying we have resources, in this case pipeline resources, that are going to be a part of this trigger. So the source is where it's coming from, and the pipeline piece is what we want to trigger. So you'll see when we execute this pipeline, we're going to kick off the hub deploy pipeline itself. Once that is done, it will automatically initialize and kick off the spoke pipeline immediately after. But it's not that the hub pipeline code goes and calls the spoke. It's actually kind of reverse, where the spoke pipeline will watch the hub pipeline and wait for that ending kind of trigger, that completion, and then know it can be kicked off and trigger its process. So this is how you can kind of do what I call like daisy chaining, pipeline chaining from one to the other as part of an end-to-end workflow that we'll actually see live, which is right now. So if you can confirm, you can see my screen still there, Arlen, with VS Code.
Yes, it looks perfect.
Awesome. So this is an example of the YAML file for the pipeline deployment, in this case for the hub. All of this is exactly what we showed in the presentation, so I don't need to kind of go through all of this bit by bit. Just want to show that this is literally the code that we're executing. If you're familiar with the intermediate edition that we did of this presentation, we've got deployment of the code, which is calling the different modules, in this case the shared services module, and then calling the peering and the spoke, and then the peering after that, and then the modules within there and so forth. So we don't need to dig into all of that. We want to kind of focus on the actual execution. So if I go back here and refresh this, so nothing up my sleeve, I don't have anything sitting here just yet. Here again, same kind of, here's the repo with all the content. First thing I want to kind of show is that pipeline library. This is where we have that variable group that we were referencing in the pipeline code. So we created this. If we go in here and take a look, we see that we have it linked to secrets from a key vault. When it refreshes, here's my subscription, here's my key vault that I'm linking it to. And if I were to go here and hit add, it reads from the key vault and says, what keys do you want to make available to this pipeline? And you can check those off. So this is where it's getting the SPN password and also the SAS key for the storage account to store the state file specifically. I have a VM password in here, but I don't have a VM being deployed at this time. So this is kind of where you can kind of control that, those sensitive pieces of information. The developers that are maybe coding against this to trigger against this don't need to know those values. You can just say this is the name, the property name that you need to put in your code, and it will obtain that right information because you'll set this up here. You look in the pipeline, we can see we're going to go into our hub deploy, and I'm just going to go edit real quick to kind of show. So again, same thing. This is exactly the same code. I was just testing against the text file to do individual testing. We're passing all the pieces in. We have, we're doing a version pinning specifically, all the same stuff that we showed in the example in the presentation. So when I click run, I'm going to say go ahead and run. Wait for that to trigger. We can go into the job, and then we can actually watch this execute. So we're going to wait a second while this kicks off this process, and then we'll kind of go through some of the pieces that we see it's doing here. So it downloads the secret, right, from the vault reference there. It does a checkout on the code while this is kind of going. It does the install of Terraform, right, automatically into this environment. Notice it's installing version 12.26, but it is telling us, okay, well, there is a newer version, 12.28, but it's still respecting that pinning that I did in the code, right? Spits that out, and then logs into Azure. Here's my environment that it's going to trigger against, and then does Terraform init, just like we've done in our previous sessions before. It initializes the module, right? It says, here's the providers, everything looks good. Now it's going to continue down this process with plan, and then it does its normal Terraform plan process, right? Here's what we're going to create. I scroll all the way down because there's a bunch of stuff in here. 14 resources are going to be created. And then we trigger the apply, and then we see it's kicking all that off to create that. And then now it's done. So if we go back to the portal, if we do a refresh, now we have our shared services resource group. In there, we have our virtual network and an NSG that gets associated there applicably. And just to prove there's nothing up my sleeve, there's no peering sitting in here right now. If we go back to the pipeline, we see it is automatically now triggered that spoke, or really the spoke was listening for the hub to be completed. So again, if we go in and take a look, it does the exact same thing, but respective of the spoke code, right? And now it's completed that job. If we go back one more, we will see in just a moment. There we go. Now the peering is getting kicked off. So if we go over here, if we go and refresh our resource groups, if the portal would like to not be a little slow sometimes, it is there. It did finish. Let's refresh. While that's kicking off, let me go take a look at the spoke real quick. Yep, no errors. Maybe it's just the portal is being a little bit slow. Well, that thinks, making sure my internet is not down. We can take a look at the peering while this is executing. Come back. Ooh, come on, portal. There we go. That scared me for a moment. Same thing, right? Terraform install, init, plan, and apply for the peering, as it calls each of these modules separately. And now if we go into our prod one, we have our VNet, we have NSGs in here. And then if we go look at the peering is now connected to the hub. Everything's good to go. And so that's kind of how that kind of works together, where you're telling from a trigger perspective, the pipe to wait and watch for the previous one. It's not like a push, it's more like a pull. So keep that in mind in the workflow that you want to kind of daisy chain together, depending on what you want to do and the order of operations that you want to execute against. So let me go back here. Before we move on, is there any questions in the chat, Arlen?
Aiden, can you speak a little bit to how you're managing that TF state file for each of these
Sure.
deployments?
Sure, absolutely. So in my case here, in this one example, I'm just using an Azure backend. So notice in my actual TF code, I am referencing an Azure backend specifically, but I don't have any of the other properties listed within the normal way you would configure the backend. That's because in the pipeline itself, when we do that Terraform init, which is a little hard to see if I make it a bit smaller, when we do the Terraform init, we're actually passing that in, if you remember in the presentation, might have been easier to see, but we are passing in those pieces of information that it will expect when using Azure storage in this case as the backend state store, but you can configure it for anything else, right? AWS S3 bucket, Terraform Cloud as a state file, that type of thing. You just can't really do it with local, right? Because then you're going to lose that because it generates it and runs it all inside of a container, which is destroyed as soon as it's done, right?
Yes. Okay. I missed that part, line 44. So
yeah,
that's good. Thanks.
Cool.
So Aiden,
no problem.
There are two more questions.
Sure.
The first question is there a reason to use separate pipelines instead of stages?
So yeah, good question. It would depend on kind of how you want to organize your stuff, right? If you ever wanted to be able to control it independently, because I have 3 separate pipelines, one for hub, spoke, and peering, deploying, and then the same for cleanup, allows me to individually trigger, say, just the peering pipeline to test that execution versus having the stages inside a single pipeline and then having a little bit more complexity controlling it. But you can do it that way too. It's just more relevant to, like, obviously how you in real world you want to do that execution and control that. Yeah, but good question. I don't really think there's like one true right answer to that.
Thanks, Aiden. There's one more question.
Yep.
The question is there a Terraform destroy in the state file?
So Terraform destroy is a Terraform command. So the state file doesn't hold commands. It holds basically Terraform's view of what it thinks the real world is from its perspective of what you've deployed and managed through your code. So you would execute Terraform destroy. If I pull up actually one of my cleanup pipelines and just go edit, you'll see the code is nearly identical, except I'm not watching all the other files, right? I'm just going to control it individually. All of this stuff is all the same, but really, if I can hide the tasks a little bit, same thing with the login, same thing with the init, because we want it to reference an existing state file, because that's what we need to execute against. But instead of Terraform plan and apply, we are actually doing Terraform destroy and passing the SPN credentials into there for it to do that destroy and the vars file that we're using. So Terraform destroy is not in the state file, but it is used against the state file when you're trying to do, say, a cleanup of your environment. Does that answer the question?
Yes, thank you.
No problem.
So Aiden, we have another question. This one is from Rasto, and I'm going to invite Rasto to come off mute and ask you the question. So
yeah,
Rasto.
It's about peering failure. Yep, go ahead.
Thank you, Alan, and thank you, Aiden, for the great work you're doing. So my question is about, like, when you run the pipeline and you actually do the deployment, and let's say the peering failed during that when you're running it, and you decided that instead of rebuilding the whole thing, maybe you're doing so many other resources that are successful, and you realize that this was a very small thing, you can just go and do it manually between VNets. And now, if you do that manually, is it possible to update the state file to reflect that change without destroying the infrastructure?
Exactly. Yeah, good question. And my good friend Depeche, who's awesome on these calls, help answer some of these questions. Absolutely. So first and foremost, I want to kind of say you should, if you're using infrastructure as code, especially if you're using Terraform, which heavily relies on the state file as the kind of carved in stone line of truth that it executes against everything. Don't do it. Like, get away from the habit of doing anything manual. Everything manual is like no go. Stop everyone from doing that, because you're gonna make more work for yourself down the line because it won't match, and that's the problem, right? So in this context, yes, the answer is yes. So let's say there's like a critical Sev A type of issue, and it's like, forget the code, just get it working because we're losing $1 million an hour. So someone goes in and they makes the fix, so everything is operational. But then that's not in the state file. Terraform doesn't know about it. So the next time you go to execute a plan, it's going to revert what you did, or wipe out what you did, or modify it in a way that you don't want it to do it. To bring that into the state file, as Depeche put in the chat, you can use Terraform import to take an existing resource and its configuration and import that into the state file. Now it's a little bit more involved because you got to get the resource ID for the object. You got to import it in the state file. You got to write the Terraform config code for that object and do some linkage there so it knows this is the type of resource, blah, 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 the properties that it needs to know about to bring it under Terraform management, but you can absolutely do it. It's not, I wouldn't say it's trivial, right? There's a lot to it, but it is absolutely possible. So if you're coming into like a customer's environment and they say, we want to use Terraform, but we already have 10,000 systems deployed and all this other good stuff in Azure, what do? We don't want to, like, it's brownfield, not greenfield. We don't want to start all over. You can absolutely do that. It's just a little bit more work to get that proper rhythm down. To make that work. I did read a really good book recently. For those that know me personally, I read quite a lot on Terraform, as I always do. There was a section in there, I think even a full chapter almost, on Terraform import and actually walking you through the steps on it already exists. Okay, step one, you need to do this for the import, get the ID. Step two, you need to, check that it's in the state file. Now we got to write the config file. Then what about these properties that aren't needed? Throw these away and so forth. The different methods. Take a look on my blog under resources and then technical book reviews. At the bottom, there should be a link to one of those Terraform books I've read recently that has my personal highlights from that publication in there. Or just ping me later. I'll have my contact info up later, and then I can make sure I get you that direct info.
Thanks, Aidan. That's all the questions we have on the chat window. If there's nothing else, feel free to continue on.
Okay, so I'm going to minimize this, and I'm going to go like this, and just thumbs up, or not thumbs up, verbal cue that, yes, you can see the slide still now. Should be good, right? I'm going to take that as a yes. Oh, and this just flipped around a little bit here. There we go. Okay, so now basically we're going to talk about the exact same thing we just did, but through GitHub and, more importantly, GitHub Actions. So again, I have a separate repo, same code, almost identical, with the nuances or differences specific to GitHub Actions in this context. So we're using a GitHub repo. We're not using an Azure DevOps repo because it's full end-to-end GitHub. We're using GitHub secrets for the SPN credentials, those SAS keys and all those other bits and pieces. And in GitHub, they're called workflows. That's AKA pipelines. We have the same kind of construct. We have multiple workflows, one for hub spoken peering, and then one for the cleanup because it's a demo to kind of reverse it all. In GitHub Actions, there's some things that are built out of the box, so to speak, or come available that people have created. Notice when you do a search for Terraform, there's a whole bunch that come up in the list, but there's one officially by HashiCorp to set up Terraform, and this will kind of do that CLI setup and so forth. But note what I highlight in the text, that this action built by HashiCorp is specifically produces the code for the config file for Terraform Cloud and Enterprise. So it thinks, or it assumes, you want to use Terraform Cloud or Terraform Enterprise for your state file. So that's a big kind of thing I want to call out, which we'll touch back on in a moment in a couple of slides. It kind of does, standard wrapper thing. There's other GitHub Actions specific to working with workspaces, working with Azure specifically, right? Whereas the HashiCorp one is generic Terraform and cloud agnostic, as it is. And then the checkoff thing is more of a validation kind of engine process as well. So that might be where you want to start, but you're going to want to adjust that specific to where you're going to store your state file and how you're going to interact with that. So again, going through the same type of thing. The coding is a little bit different, right? We're watching the master branch. Right now I'm watching my text file because I'm individually testing things, but you can put your other files in here. This is what's going to trigger this workflow or this pipeline to execute under GitHub Actions. Same type of construct. We have the variables within the environment that we're passing through, right? We are, instead of using Key Vault, we're using the secrets engine in GitHub itself for the SPN credentials, or to log into Azure, or to access the storage account that has the state file, right? So a little bit different, but not too bad, right? You just got to know kind of how do you reference that now. So where do you have to change your code to make that applicable, right? That's where this secrets dot whatever is. The workflow of this is what is being executed. So we're highlighting the working directory. This is that root of where the job is executing against. So here I'm focusing on my hub deploy module, which then calls my actual hub module. So I can keep deployment separate from the actual code that deploys or that creates the actual VNet in this case, because then I can go and very easily just add stuff to that other module. Say, if you saw my intermediate presentation, we have things like Azure Firewall, the site-to-site VPN gateway, or the ExpressRoute gateway, and all those other bits and pieces you could put in there as part of the hub deploy, or as the hub module rather. And hub deploy just needs to make sure it passes the right variables that those other pieces or those other resources might be looking for as part of that execution. Now here's the steps for a GitHub action. So it looks a little bit similar to what we did, maybe a little bit easier to read. Notice that we, again, have a pinning for the Terraform version. I have it commented out in this case specifically, but again, you can still pin it, which is a good best practice to align it to what your code is tested against. So there's no potential issues with using a newer version of Terraform that might have a breaking change, or where a good example would be, let's say we had to go and modify something in an existing resource in the provider because a new property was added or a property name was changed, that we sometimes do at Microsoft. We know we change stuff sometimes. So things like that, doing that pinning, then at least you know you've tested your code against that version and that version of the provider, and you're good to go. So you want to make sure the workflow aligns to that same coding version, right? Same thing with Terraform init and plan. We're saying we're passing variable files in. We want an out plan file for the artifact, and we're going to apply that, and we're using the auto approve against that. Now, here's what I want to call out from my experience with this. When you're using GitHub Actions, you cannot use modules with a relative path. And so what I mean by that is that first code example on the right, which is very, very common, at least what I use. So I have separation of directories of deployments and services and bits and pieces to make it as modular as possible from a coding perspective. You cannot use this kind of whack traverse of the directory to point to another module. It is a known issue, but it is specific to when you're using Terraform Cloud as your remote backend for your state store. If you use Azure, like an Azure storage account, which I had to switch it to make it work, it will work. If you don't, you'll get this error that's at the bottom where it says error unreadable module directory, and it's like this path doesn't exist. Well, it does, but the link, it doesn't understand it. Now, I call this out specifically because remember, if I go back up a couple slides, if you're using out of the box this HashiCorp setup Terraform action, and you're not aware of these other actions around Azure Terraform setup or workspaces or other things you can customize around that, you might just deploy, or someone might just deploy and say, okay, I'm going to use the official HashiCorp one because that's got to be right. It's going to look for Terraform Cloud or Terraform Enterprise, and then if they have something like this relative path from a module perspective, like you saw in my code, they're going to get an error and not know why this is happening. So something you want to just definitely keep in mind when you talk with your customers or in your own operations in doing this, because it will throw you off. I had to do a bit of research to figure out, well, what's the problem here? Why can't it traverse the directory? It's simple, right? It's because it was pointing to Terraform Cloud as that remote state. So keep that in mind. The other thing that you can't do, unfortunately, is trigger another action or workflow after one is completed, like we did in the chaining for Azure DevOps. So once my hub was done, my spoke was listening for the hub to be completed, that pipeline to finish, and then it would trigger itself, and then the same thing with the peering. You cannot do that, unfortunately, with GitHub Actions today. It is something they're working on to provide from a feature perspective, because hello, that's how we do things, right? You don't do one big giant workflow that's not modular and DevOps and all the other fun buzzwords. So keep that in mind if you're going to start to shift into GitHub Actions. Some of those limitations are there that might be a bit of a challenge on how you're going to execute your code like in a daisy chaining process. One other thing that's not great is that you cannot manually trigger an action or workflow like we did in Azure DevOps, where I just hit run pipeline and go, versus having to go make a modification to a file and push it up to the repo and then letting it trigger. You cannot manually trigger it, say, for your own testing and validation of it. You're going to have to go and modify whatever file it's watching, push it to whatever branch it's watching, and wait for that to trigger. So that I found a little bit annoying from a testing perspective, because I don't want to have to arbitrarily change stuff just to test to make sure, did I work out that bug in the pipeline? The last point is kind of, again, tied to the first point. It's not apparent that you can use an alternative backend like a storage account when you're using that built-in out-of-the-box GitHub action from HashiCorp for Terraform, because, again, if you're not aware of this limitation, you might just think, oh, well, it's already there. It's from HashiCorp. It's official. It's great. And it is. But some of the limitations that we found can make that a bit of a challenge. So knowing that you can make a change, you're not tied to that, gives you at least more flexibility. Now, I was going to demo how this worked, but I want to check how I'm doing on time first to be respectful of everyone's time.
So
and if
we're
there's
at the,
questions.
So there's no new questions, Aiden. We are at exactly the 1 hour mark.
Okay.
And so you could plan your time accordingly.
Okay, so what I'll do then, if everyone is cool with it, I'll keep going. That way we can at least get through the content, so that so everyone has the information, especially the gotchas in all of these that I've found, so that we have the information for everyone. And then at the end, if there's a good amount of extra time, which is fine, then I can definitely go and trigger them to show how those work live as well. Okay, sound good? I'm going to take silence as a yes. Okay.
I'll say yes, Aiden. So yes, that makes a lot of sense.
Yeah, that way we're not rushed for the actual valuable information for everyone, and then I can always show it afterwards. That's fine. Okay.
Thanks,
Yeah, no problem. So now we're going to do the exact same thing that we just did in Azure DevOps and in GitHub Actions, but now we're going to use Terraform Cloud. So again, I have a separate repo. It's basically a duplication of the same code with whatever slight modifications needed respective of Terraform Cloud itself. So I'm using a GitHub repo specifically for this this part. It's not like Terraform Cloud, the free version, has like a repo built into it. I tried to convince HashiCorp to give me access to like Terraform Enterprise or the paid version of Terraform Cloud to do a real full end-to-end, but that hasn't been successful thus far. But if and when I can get that, then I can kind of come back and update this applicably for some of the other features. But I'm using GitHub repo. I'm using the variables within Terraform for the SPN credentials, all the stuff we were doing before. One thing to call out, when you're using Terraform Cloud, a workspace in Terraform Cloud is effectively one state file, one store, if you will. Whereas in the previous examples, we can use the same Azure storage account, but point it to a different container or point it to the same container, but just a different state file name itself and be fine. With Terraform Cloud, it's like a one-to-one mapping. Workspace is where a state file is stored and all the metadata around that. So that's where you're going to keep that separate. So for deployments, we have a workspace for Hub, Spoke, and VNet peering. And I make a note about the cleanup where we saw in the other ones, or at least in the Azure DevOps one, and in the GitHub one that I didn't show yet, I have a cleanup pipeline, right, to kind of revert my demo back to blank. You don't have to have a cleanup workspace or a cleanup pipeline in Terraform Cloud because that's actually built in to the workspace itself. You build it for create, and then there'll be a button or an option to trigger a delete against that workspace. So a little bit different, but pretty neat to kind of see. So how does this kind of work? We already talked about kind of how it separates the state files a little bit there. It's like a separate working directory from what you do, say, like locally, right? Where you're triggering your Terraform init and plan and apply from, right? And then where it holds that state. And, you know, it does the state locking. It has the previous versions to kind of revert, which is great. Lots of flexibility there, and it has this run record of activity. When you're executing, you can go and see, okay, this one failed, this one passed, this one was queued and hasn't been executed yet, and so forth. Right. So there's some other nice stuff around that from that perspective. Now, again, I'm talking about Terraform Cloud, the free version. So there might be other features or gaps that I've identified when I've tested it that are in the paid version that I just haven't had access to. So just kind of keep that in mind from an enterprise or a professional usage perspective, because maybe your company or your customers will pay for Terraform Enterprise or pay for Terraform Cloud, like the paid version, and have some of these other features that I did not have access to. With triggering in Terraform Cloud in the workspace, it has like an automated one or a path file change detection. But note that this has to be within the working directory. So when you configure the workspace where you're telling it this is where my files, my Terraform files are, that's where it's looking. It cannot look outside of there. So you see in this example, I am pointing to the hub deploy working directory. I tried to add additional ones, additional paths, either the hub trigger hub.txt at the root of my Terraform directory, not in the hub deploy directory. And I also tried to put a path to traverse the folder directory, if you will, back up to the root as well to see if that would work. Those two things do not work. So it has to be within that working directory. So keep that in mind when you're configuring the workspace on where you want to trigger the deploy. on how you want to organize that. So when you saw previously, I had a hub deploy module effectively, and a spoke deploy module, and then the peering module. Those would be each individual workspaces at the root of where those main.tfs are, where those variable files are, where it's going to be triggering from. Here's something else that I discovered, which I wasn't too pleased to discover, but first and foremost, Terraform variables versus environment variables. For some reason, when I had things in environment variables, it didn't work. It didn't pass those values through. Now, I might have possibly done it wrong. It is possible. But I had to switch them. You'd think environment are all up, right, in the entire environment and pass it through. But for whatever reason, it didn't work. I had to switch it to all Terraform variables specifically to pass those IDs and that SPN password and so forth into the Terraform command line. Also, something I didn't really super like is that you cannot have a custom named Terraform TF-vars file, right? I like to name them respective of what they are and, like, say, region that they're being deployed or something to that effect. It does not like that. You have to have an auto.tfvars file. You can put whatever else in front of auto with the star, but that's the pattern it is looking for to execute. So when you have your Terraform plan and you see the command line, that var file reference has to be whatever .auto.tfvars. So didn't quite like to discover that, because that meant the exact code that I built for Azure DevOps and GitHub had to be modified specifically to work with Terraform Cloud, and not in like a common sense way, right? It shouldn't really matter, because if you've worked with Terraform, you can use whatever you want to call it, .tfvars, and just pass that in on a normal command line, but Terraform Cloud did not like that. When we execute our workspace, our pipeline, it's called workspace runs. We see in the screenshot, this is where it shows, okay, I canceled one because I had to go fix something, or something was applied, something had an error. And this is that history, that run list, to show, in the context of that specific workspace, right? So I'm doing the hub deploy or the spoke deploy. This is when it's ran, what happened, what was the results, and so forth. You can queue up a run, which is great. So that's that manual kind of trigger if you're going to do some testing, which is awesome, which some of the other ones that did not have. So that's cool. And the workflow around that wasn't too bad to kind of trigger that and watch that go. Here's an important thing I need to call out for everyone that wants to look at Terraform Cloud. Again, this is the free version. It could be, this is not an issue for one of the paid versions. I do not know. When you're running a trigger for your workspace, notice that here I'm saying, okay, this is my source workspace that's going to create this run. So this is where I'm trying to do that pipeline chaining thing, right? In this case, it'd be like workspace chaining, because each of them are effectively their own pipeline. I want to kick off spoke after I've done hub. Notice this warning, which is in blue. I would kind of think it would be an exclamation mark in red, but notice this warning, the auto apply warning. This means that you have to actually manually approve and apply. It will not accept the auto apply parameter that we've used in our Azure DevOps pipeline and in our GitHub Actions to do a real end-to-end trigger. Why this is the case, I don't know. To me, it seems really odd that this would be the case from a whole real DevOps pipeline process. But again, this might be because it's the free version. If anyone has experience with Terraform Enterprise or one of the paid versions of Terraform Cloud, please do let me know if this is the case or not in the paid versions. That would be good for me to kind of make a note here.
It's not. So after a plan is done, you need to confirm before the actual apply would happen. So you
Even
get
even in the paid versions.
in paid versions, yes, you can either
Wow.
set to auto apply or it will wait for you to confirm. You have an option to turn off that option.
Okay. Well, so this. See, but with this, when I was trying to do the daisy chaining between the pipelines effectively, it will not accept an auto apply. It would always stop and wait for me to hit apply to finish the one pipeline before it would move on to the next one.
Okay, I haven't tried Terraform Cloud in a while, so I can't really speak, but I'm talking from Terraform Enterprise experience.
Okay, excellent. Thank you. Appreciate that. So that's just something I discovered. Thank you. I don't know who was speaking. My apologies, because I only have one screen up, but appreciate that a lot. And it's just something to kind of keep in mind when you're looking to use Terraform Cloud. If you have a contact with HashiCorp, if you have Terraform Enterprise, whatever, kind of make a mental note of this, because if this is the case in the paid version, well, then how do you do that chaining? Or what's the workaround or the approved flow to do a real end-to-end chaining of different pipelines effectively? Something I just wanted to really kind of call out, because that was really kind of annoying to find. And it took me a while to kind of do some research on why this was happening specifically, because it's not really super apparent, right? So just to kind of sum up some of the points to remember from this, we've already talked about, you cannot, unfortunately, have a custom named TFRs file unless you use the auto construct of the naming convention. Is it like a showstopper? No, not at all. But it still does mean that now you need to possibly change your naming convention for your code files from a team perspective, if that's what you're going to use. The workspace working directory controls the route where the Terraform init is being executed. You can't kind of traverse the different directories within there or outside of there from that working directory. So think about that from where you want to execute your Terraform init, plan and apply, and where you want to point that Terraform Cloud workspace to from a working directory perspective. Something else that I found really kind of interesting, slightly annoying, is because I did not have to create a separate pipeline or workspace specific to Terraform destroy for like a cleanup action like I did in Azure DevOps and GitHub and the GitHub Actions. Because in Terraform Cloud, you have the workspace with your Terraform init and plan, and there's a delete or cleanup option against the existing one. If you try to do that chaining together, like where even though you can chain it together, but it's going to wait for you to hit apply to finish, you can still chain it, but it's not fully end-to-end automated. When you go to trigger a delete for cleanup, it will trigger the other chained or linked workspaces in the normal fashion that you've configured it. So in my example, when I was doing a delete hub to clean up, it will trigger the deploy spoke, because basically anything that's done being executed against my deploy hub workspace, even though I'm doing a delete or cleanup against it, I'm triggering against that workspace. And then once that's done and I hit apply, because yes, I want to clean up, it will immediately trigger the spoke deploy because it doesn't understand I'm cleaning up. So I found that a little kind of challenging to work with. In that context, the spoke would deploy, but then the peering would fail because the hub no longer exists because I did a cleanup, right? So I kind of had to backtrack a little bit to get things cleaned up properly. But I found that a little bit of annoying in that kind of logic where, well, how do I kind of revert one without trying to automatically create something else, right? So just a point to remember there. And we'll come back to that time pending afterwards, respective of everyone's time. All right, so now we're going to talk about resources for learning stuff. Bonus points for anyone that knows where these cards are from, because I am a big fan of this game. For those that don't know, this is the Settlers of Catan. and I actually own all of them, plus the Star Trek version and its expansion. So we should totally get together when we can after this is all done. So a bonus resource I want to share with everyone. This is a duplicate from the intermediate session, but for those that weren't able to attend, I want to call this out. TF-lint or Terraform Lint. It's part of the GitHub Super Linter package. If you watch the little animated graphic on the side there, where they have a code file, they execute it, and Terraform errors out because it's not an appropriate instance type, in this case for AWS. But when they did Terraform validate, it says it was fine. TF-lint validates the actual values against what is allowed and can tell you immediately if that's not going to work. So watch that for a moment. We'll see, does validate for Terraform validate, and it says it's fine. Oh, it's successful. It's valid. But then on the apply, it fails because that instance type is not actually a legitimate instance type in AWS in the example. So from a DevOps perspective, from a pipeline and code check-in process, definitely look in using TF-lint as part of that flow so that it's validated even further before an actual deploy pipeline is triggered, because then you'll prevent it from triggering any type of deployment and have partial deployed resources that were okay and then some that were not. It's a good practice to kind of add that into the workflow. So it provides provider-specific validation, not just Terraform code validation. It supports all the major clouds, so Azure and the other two, AWS and Google. And there's a bunch of rules in here that it checks against. So notice there's 700 or more for AWS, which is fine because that's where they first started it against. Now they're working on the Azure one. So there's just under 300 and they're working through that. And GCP has one right now. So again, it's an iterative process that they're adding more and more into it, but it's a really great resource from a full end-to-end DevOps perspective to build into the code check-in flow, right? Someone pushes code up to the master repo or they want to merge it in, and it does maybe this check as part of that. Really great resource to take a look at, and it's free. Okay, so now just a couple of pages, a couple slides of some resources. If you're familiar with my Terraform beginner presentation and my Terraform intermediate edition presentation, these links are not duplicates of those. I very specifically and purposely choose links applicable to the topics of our presentation today, with the exception of the first one, because that's my personal curated list of resources that I have used in learning Terraform that kind of spans all three. And some of these other ones for helping you get to more of the advanced stuff, more of the DevOps process, right? So there's some links around using Azure pipelines, some step-by-steps on kind of doing that configuration, how you do some of the workflows with the remote states for GitHub Actions, some of the advanced optimizations, things like that. Really helpful to kind of think about in the real DevOps end-to-end practice. Of course, if you're using the Visual Studio Code product for your template authoring, then we have those two extensions that I've mentioned in the past, the Azure Terraform one by Microsoft and the Terraform one originally by Mikhail, but now HashiCorp has released. There is an update to that one from HashiCorp that they released not too long ago, the first official release by HashiCorp. And it has a bunch of IntelliSense into it. It shows you which properties are required versus optional, so it's really good. There's still some gaps that they've acknowledged, but I'm excited to kind of see where that's going to go to make template authoring a way easier, especially from a properties perspective. One more slide here for some additional resources. Misadventures with Terraform is a really good video where someone that's gone through some challenges with it, with their team, with their enterprise at scale, saying, oh, we ran into this, we ran into that. Really good to learn from each other's mistakes, because that's really how we all learn, and helps you to think about those things, even if you're not there yet from your Terraform workflow. Maybe you're not going to do pipelines tomorrow, but maybe next year or something like that. Knowing some of these things in advance helps you to think and plan in advance up front on the direction that you're going to go. How many repos am I going to have? How am I going to carve this out and organize my state files and so forth? Definitely really good articles here to take a look at. GitHub Actions we talked about, Terraform Cloud. There's the article by Gruntwork, which is really awesome resource that I used quite a lot when I first learning, deploying production grade infrastructure using Terraform Cloud, Terraform Enterprise. So understanding how we can leverage those tools and even some modules, because that's where we really want to have that code reusability that we discussed in our intermediate session, but then also from the perspective of a private module. So are we going to do it in Terraform Cloud in a private module, or if we're using Terraform Enterprise and having it on-prem in our environment and using private modules there across a larger org, that type of thing. One more resource slide here for everyone, because as we know, this comes up quite a lot around certification. HashiCorp has released their Terraform Associate certification. Myself and an Azure MVP, Ned Bellavance, we co-authored this unofficial Terraform Associate Prep Guide that we both wrote based on our personal hands-on real-world experience with Terraform. And we wrote it from that perspective against the objectives of the exams. This was before HashiCorp produced their official guides, which are also really great resources. But unofficially, HashiCorp has reviewed our guide, and though they can't officially endorse it, they've definitely accepted it as a decent, as a legitimate option for preparation. So take a look at that as well if you want some of our perspective in preparation for that. Finally, this is my last slide. This is who I am, what I do, where I work, and all my awesome contact information. Feel free to connect with me on LinkedIn or on Twitter. Hit up my blog. I do have lots of articles on there around my real world experience with Terraform. Some of the gotchas. It's not just marketing as in, oh, everything is great, right? It's the real world challenges. Oh, the provider is missing this, or you can't do this in Terraform yet today. This was before version 12, or I found this bug, right, in working with NSGs in a separate module, didn't quite work, and so forth. So real world experience from that, that hopefully can be valuable for everyone to learn from and to share with each other, because that's really the whole point, right? We don't want to reinvent the wheel. We want to share our experiences, how we got through that, so that we can help each other to move past that, or ideally not hit some of those roadblocks, especially for projects that we have to deliver. I do a lot of stuff at Microsoft. I specialize in a lot of stuff. Before moving to Microsoft, I was a 5-time MVP, and I am appreciative to say that HashiCorp has awarded me their HashiCorp Ambassador Award, which is basically the HashiCorp equivalent of MVP, based on all of my experience and sharing really with the community around Terraform in this context. So I'm going to be quiet now and see if there's any questions, anything else. I want to be respectful of people's time, but also want to make sure there's enough time for everyone to get any additional questions answered.
So Aidan, there's two good comments from Depeche there. If you want to have a quick look and this comment on it, or just read it out to the people, or any thoughts you had on those topics.
Sure. Okay. So is this starting with the you can't have a custom named TFR file?
That's correct. Yes.
Okay. Yeah. So I'll read it out just for the recording purposes. So he says you can't have a custom named TF-vars file, probably because you don't have an option to specify which TF-vars file to use anywhere in the settings, and should instead use the variable settings in the workspace. Terraform Cloud or Enterprise automatically creates a Terraform.tfvars file based on the variables set in the workspace. Okay, good to know. Thank you. Appreciate that. And the auto.tfvars file automatically loads variables, as it will bypass the requirement for you to specify a vars file and automatically loads it. Awesome. So appreciate that insight, Depeche. Absolutely. I haven't had that opportunity to dive into like the enterprise level of Terraform specifically, or in that in that context. So really appreciate that insight that you've shared from your experience with everyone. That's awesome. Let's see. There's also one there. This is also one great reference about the best practice. So he's just sharing a link to terraform-best-practices.com. No, I don't know. I have to check if I've hit that site before, but appreciate that that share as well. I'll definitely add that to the deck and to the list for everyone. So.
Thanks, Aiden. So that's the list of questions or statements or comments on the chat window. We could open up to anyone who wants to come off of mute and ask you any questions. So let's see what people have to say.
So John's got a question here about, I would like to know, what is your perception when creating modules? Would you wrap resources just to create a module, or would you have some sort of dot points to make that assessment? John, if you don't mind coming off mute, like to maybe elaborate a little bit on that. Are you asking like how granular would I go?
Yes. Well, I'm currently in that situation, and it's like we got a set of modules. We got lots of modules at the moment, but sometimes you use that module as a nested module into another one, yeah, like a composite module.
Like a sub module, right? Yeah,
like a sub module, yes.
Yeah.
And now we're looking at it, and it's like, I don't think we should create a module just for this, just for have a module, because it's a wrapped resource.
Yeah.
So it's like, yeah.
Good question. Yeah, I understand what you're saying. And some of the links that I put on my blog from my personal learning resources have links to some videos that really helped me see how a team would progress from like a one-person team to a multi-person team, and then how that dynamic would also apply to how granular do you get with modules and submodules, like to what end, to what point. A good example that I've seen and done in the real world would be having one module, in this case for Azure, for the compute or for a virtual machine, right? Because you have like a higher level module for compute or VM, but there's a bunch of sub modules inside there. There's some for like disks, there's some for like availability, there's one for like the network card, all these other bits and pieces, right? And I still have sub modules for, say, like disks is a good example, because even though I want to call the compute or the VM module and then create whatever, I can still reference that sub module directly for any other resource type that needs a disk. So a good example of that is virtual machine versus VM scale sets. They can both use data disks. And if I have a sub module for data disks, then I can just with the proper notation, point directly to that data disk submodule, because it's a module within a module, it doesn't care, and just call that directly. But then it's like, how granular do you get? Because then it gets really more complicated, because then you got to bubble up all of the variables that are required from the lower level module to the top to make sure everything's passed through, and the same thing with the outputs to get that back out too. Yeah, so I don't think there's a real like, it shouldn't be lower than, say, like 3 nested modules deep kind of thing. I don't know if there's like a definitive rule that I've seen, but the deeper you go for like a sub-module underneath sub-module, the more complicated it gets to map it out on, okay, I need to pass this variable and I need this output that goes from level 3 to level 2, and then from level 2, I need that back out to level 1, and like traversing it backwards can get a little complicated.
Yeah, it's true. And also the management overhead that comes with it.
Right, because someone coming in has to look at all your directories and then understand how those are stitched together, right, to be able to, like if they're going to take over the code, for example, right, if you're passing it off to a customer or something. Yeah.
Or if you make an update as well, because if you make an update, then your version, you usually use version pinning.
Yep.
So then you have to go to the other modules to update a new version to the latest.
Yeah,
version.
exactly.
So,
There was a good video I saw when I was first learning about that, or maybe it was an article, but I think it was from Gruntworks specifically, where it talked about like how they've written, I don't know, 300,000 lines of code or 3 million lines of code or whatever. And he had a slide that showed how he breaks it down from a resource to module kind of mapping. So it's like how many folders effectively does he go in? And I think I want to say 3, but it might only be 2. But that should be on my blog, I believe. If it's not, I'll try to dig it up and put it up there on my personal curated list. And then because I found that really helpful too, because when you're just starting, it's you put all the code in one file, and that's great to make it kind of work or a POC. But then what do you do when you actually need to kind of productionalize it, enterprise it, at scale it, right? And then break it all down into modules for more repeatability. Yeah.
Correct. Excellent. Okay, thanks.
Yeah, no problem. So Depeche says that he's been working on a few projects that use Terraform Enterprise, so he's got recent exposure. Yep, appreciate your input. Absolutely, Depeche. Thank you always for joining and sharing that insight, because that's something I haven't, unfortunately, had the chance to get a lot of hands-on with the enterprise version of Terraform explicitly. So appreciate your real-world input on that. That's awesome. Thank you for sharing. So we have a little bit of time. I don't know if anyone has any other questions. I can put this back up if people needed my contact info, and or also if people wanted me to show them any of the other stuff, the GitHub workflows in action or anything like that.
Aiden, I think you missed a question from Rasto, right?
Oh, did I? Oh, I'm sorry.
Right above John.
Oh, okay. Oh, I see. Thank you. Yeah, I did miss that. So Rasto asks, between Terraform Cloud, DevOps, so Azure DevOps, and GitHub, what is your preference? Ooh, that's a difficult question because I work for Microsoft. No, I'm kidding. Truthfully, transparently, based on even doing what I kind of classify as a fairly simple demo, a hub and spoke network topology with peering isn't that complicated, right? It's not like this multi-geo thing. Looking at what I can do with each of them and what limitations exist with each of them, again, respective of not having access to the paid version of Terraform Cloud. Out of all 3, right now, Azure DevOps is the most mature from a flexibility to work with the different pieces of Terraform and making it more flexible for what you need to do with the different pipelines and stuff. Azure DevOps is number 1 right now, in my opinion, with GitHub Actions coming a close second. There are some gaps that I mentioned, but the team is working on those. So I expect that to be pretty much on par sooner than later. Hopefully, I don't know officially, I'm not on that team, but from a gaps perspective, from a flexibility perspective, Azure DevOps right now, in my opinion, is still the best choice, with GitHub Actions coming closely behind, and I'm assuming will be on par shortly.
So there's a comment there by Depeche, if you want to have a look at that too.
Sure. So for just infrastructure, Terraform Cloud, full CI/CD with code deployment, Azure DevOps, GitHub, GitHub's not fully mature, or are you saying that also? Are you saying for like
GitHub is not fully mature because you can, like the way you pointed, it's not fully mature. It can do chaining and all those things.
Yeah.
Right.
Yeah.
So
okay.
yeah,
I get. Yeah.
it
Appreciate
it. To...
Yeah. There's still some of those gaps, and some of them are a little bit painful, right? Especially for that chaining thing, right, and the flexibility around that. But obviously, we're gonna get there, especially because the Azure DevOps team is the GitHub team now, and vice versa. They mix together. So we're obviously going to see that for sure in the future. But it's just obviously right now, today, yep, not quite there yet. And also from Depeche's comment that ADO, Azure DevOps, is right now one of the most mature DevOps solutions that we have. So yeah, that makes sense. Awesome. So we still do have a bit of time, which is great. If I pop over, not to here, if I go here, and I should have my GitHub up here. So the workflows. So basically the workflows in GitHub is kind of basically similar, right? It's all written in YAML as well. It's got some comments to kind of give you some examples here, right? Remember when I talked about the initial Terraform action? So it gives you instructions here about the main and having the remote to your Terraform Cloud organization reference and the workspace reference. It's not apparent that you can actually not have to use that, and that's what might throw people off at the first kind of go round with that. But it's nice that it gives some instructions on generating the token and making everything kind of work and how you reference that specifically and then trigger that off to go. Same type of thing. Little bit different, right? I've got environment variables specifically being applied. I'm applying that plan file again after I've generated it in the Terraform plan execution, passing some of the other variables in for the tokens, right? The secret stuff from the store. Let's see. Thanks, Mike. Yeah, any other questions? Anything people want to see that we didn't get to see? What about you, Arlen or Ezekiel? Any thoughts?
Nope, this was a great presentation. It's fantastic. I'm going to watch it again later and go through the slide deck again a little bit more carefully. But no, it was excellent, and it was really, really a good end to the three-part series, and it goes into some really technical details. And from a DevOps point of view, it was great. So I found it very, very helpful and very useful. But I have no additional questions at this time, Aidan.
Yep. So I'm just showing here real quick, right, in the GitHub Actions, same or similar type of output that we saw in Azure DevOps, right, in the pipeline, right, Terraform init, initializes with the backend and the modules, all that other good stuff. Standard kind of Terraform stuff, right? Here's the stuff it's going to execute on. So pretty straightforward, but it's interesting just to kind of see. Really, it's more the code for the action for that pipeline. How that looks, say, different than what we write in the Azure DevOps pipeline from a code perspective. But other than that, it's all pretty much kind of straightforward. Same type of process.
So Aidan, we had a question
Sure.
from Vlad asking, will there be a part 4?
Sure. Well, that I'm going to ask Vlad to come off mute because I know him personally, and say, what would you like to see in part 4, or everyone? Kind of, if you have any thoughts, put them in the chat or come off mute. Right now, obviously, this is a 3-part series. We have the beginner. This is what Terraform is. Intermediate, reusability and modules and all the good stuff. And then this is part 3 with the whole end-to-end pipeline DevOps stuff. What does everyone kind of think or want that would be appropriate for like a carry-on or a follow-up for a part 4 on this?
Yeah, I think I just got one more question. Obviously, I'm using Terraform Enterprise currently, and we use it a lot for infrastructure as cost.
Yep.
But there are instances where we would like to deploy application. Just the application. Let's say I set up an Azure function, and I would like to deploy the application, do the deployment for the application as well. Obviously, doing it by
the rest.
Yes, obviously Terraform doesn't. Well, you can do it with Terraform, but it's a lot of fiddling, and that's not the main purpose of Terraform.
So maybe just to clarify, to make sure I follow what you're asking for before I answer. So you're saying you kind of want to see while we're going to use Terraform and we deploy our our networking and our infrastructure pieces, but now we want to see, now that say the core networking is down, I want to also see how do I, in a separate file or a separate pipeline or workflow, deploy an app into an existing environment that's also managed by Terraform?
Yes, so we are thinking, like, for example, well, we're using Terraform Enterprise as the backend, then we probably have to use another product, obviously, to do the full CI/CD. Maybe.
It depends. So interesting. It's really interesting that you mentioned that. I'm curious. I'm personally curious why you mentioned that, because I'm doing this series of presentations, part 1, 2, and 3 for the Terraform stuff, for several other user groups. And one of the user groups wants me to modify the intermediate presentation to also include the deployment of Azure Functions, SQL database, and some other like API management thing, in addition to what I do as part of the demo, which is just the base networking stuff, as part of that. So it's interesting. Once I work through that with this other user group and get a decent, more real world example, right, then I could probably fold that into the real presentation, the intermediate presentation, and make it part of the actual presentation versus a custom presentation for this user group. But yeah, it depends on what you mean by deploying the app, because you can use Terraform and say, I'm going to deploy all the core networking and all the baseline stuff and get that managed by one series of Terraform templates and state files. Like you'd say the networking team would manage that. But then if you watch the recording for the intermediate version, or if you were on that, attended that, I talk about how you can use like things like data sources and remote state as data sources for, say, an application team says, here's my app that I've defined in Terraform, the pieces that my app requires, but I need to reference something that already exists in another state file or outside of Terraform and use that as part of still the deployment. Now, that's just deploying of the resources, right? Let's say it's deploying virtual machines. A bad example, I know, but deploying virtual machines. Terraform can deploy the infrastructure, but you're going to want to use, as part of the beginner series of this beginner presentation of this series, you're going to want to use a tool that specializes in configuration as code, like PowerShell desired state configuration, or Chef, or like Ansible, or something like that, which it specializes in the config side and not the infra side. So you use Terraform to deploy the infra, and then you can use Terraform to actually trigger Chef to apply a specific cookbook or recipe against that environment as part of the config as code process. So that some of that kind of is still infra and IT ops related, but still also applies to, say, like an application deployment perspective too. Does that help? Is that kind of what you're looking for?
Yeah, that sort of stuff. Because the moment is like, okay, we want to deploy the infrastructure, but at the same time we want to apply the Node.js part of the function
on top of it. Yeah. Yeah, and then we kind of get into even more complicated things from like a Kubernetes perspective. For example, you can deploy your Kubernetes cluster and all its kind of main pieces through Terraform, because there's a provider for it now. But then you can leverage something called GitOps, which basically tells your Kubernetes cluster to watch a specific GitHub repo for the Kubernetes configuration files, and as you update that in the repo from a config perspective, Kubernetes will immediately pick up the change and then automatically apply those changes into that cluster. So that you there's lots of different things you can kind of mix and match depending on one, like what technologies you're targeting and like what the applications kind of need and the flow in the process. But it's definitely possible.
Yeah, because the other thing is you start using provisioners like local exec and all that sort of stuff. Not resource, which is something you want to avoid.
Yeah.
Well. Yeah. Yes.
So yeah, definitely possible. It's more complicated for sure, absolutely, but it is possible. Yep.
Yep. Cool. Yeah, thanks.
Any other questions? So we didn't actually get an answer to what do people want as maybe a part 4, because at this point it's only been these 3-part series. What is a logical part 4, or what would everyone kind of be interested in seeing that's beyond the three-part series that we have so far?
Hey, Aiden, this is Vlad.
Hey, Vlad.
Yeah, just one of the examples. It would be curious to see how to use Terraform to manage, let's say, Azure governments, because it's getting more and more popular in like large companies, and I've seen a few examples how people actually use Terraform, but it's kind of new, and maybe you can provide some insights about it.
So, sorry.
Like management groups, RBugs, and other
policy
stuff.
Yeah. So, okay, governance, Azure governance. Yeah.
Yeah.
So actually, I do have sample code somewhere in the world on my repo somewhere. I've actually real world written Terraform code to create management groups, to associate subscriptions, to create Azure policies, and then create initiatives as groups of policies, and then assignments of that. I've actually done that. But so that's what you're kind of thinking of as like a next step, or maybe like an add-on to maybe the intermediate stuff, perhaps.
Yeah, exactly. Okay. Yeah.
Cool. Awesome. I will think about that and think about the approach I could take for that, and how I can get that done. Any other thoughts, on what you'd like to see as a version 4 or as another kind of carry-on? Real world use cases. Yep.
Yeah, so exactly what Vlad mentioned, like governance or other real world use cases based on your experiences.
Yeah. A lot of what I've done, if you watch some of the previous recordings, a lot of what I present on from this perspective of Terraform on Azure is all based on my personal real world experience. And a good example of that for a customer that I can't name is deploying a global VNet mesh peering architecture across 8 different different Azure geos, and like stitching that all together and express route circuits and all that other good stuff. So real complicated networking pieces. So between like hub and spoke, and then hub to hub, like a mesh within a geo and stuff like that. Yeah. So that's where I bring a lot of my experience to make it more relatable. But yeah, maybe like demoing something like that. Some of it might be a little hard to do, only because obviously creating VNet VPN gateways or express route circuits and gateways takes like 30 minutes to deploy type of thing. And some of that you don't want to just sit and watch. But the governance piece and the management group piece and the policy stuff, I could probably do. I do have my sample code for that I can kind of clean up and leverage. Yeah.
So yeah, Ezekiel here, Aiden, thanks. Great job on the presentation.
No
so I was gonna say, because I just wanted to let everyone know, and we're going to announce it via the meetup group as well, that we're gonna take a break in August, right?
Yeah.
So because obviously it's summer months in North America and Europe, so August is going to be off for the group. So perhaps what we can do, and I was thinking as you were asking the question about part 4, is perhaps we can put together a little Office 365 form to send the survey out, so people can respond, and we can develop the content according to the responses, right?
Yeah,
so
that's great. Yeah, if everyone is good for that, that would be perfect to put it on the meetup page once this the recording and everything is posted. And then if everyone can kind of just chime in on, hey, what else do you want to see from an Azure and Terraform perspective, that's absolutely perfect, because then we develop and present stuff that you want to see, right? Like
exactly, and we can build on the first 3 sessions, right? And people who haven't watched the sessions, they can go and watch the videos. Yeah. Right? So yeah, let's do that. Yeah.
also in few other platforms, if possible. Are you talking about like AWS and Google?
I think maybe just a suggestion that I've
Yep.
seen, I saw it yesterday, and it's about the cloud adoption framework that Microsoft is switching forward. Yeah, so
Yes.
I was looking at some of the code, and some of them is quite interesting, like AKS, for example, which is using the latest preview that using the AAD version 2, and they use a lot of fiddling to get all those preview features enabled.
Yeah, the cloud adoption framework, that's also interesting because as part of my day job at Microsoft, I actually assisted in delivering a 4-day workshop to our partners on the cloud adoption framework. And specifically, I personally delivered the governance and management piece of that presentation. So if you are a Microsoft partner, I would suggest maybe circling back with your TAM or your PDM or PTS or whoever you kind of know aside from me inside Microsoft, just in an official capacity to see if we can arrange for something that's applicable to your business or your org. That might be a little bit more appropriate because I don't quite know officially from a Microsoft standpoint if I would be allowed to do a user group presentation on the CAF since we have some official channels around that. So I'd have to kind of take that back to check personally. But speaking of the CAF, Cloud Adoption Framework, definitely go take a look at it and the new content that's been released recently around what we call enterprise scale, because it actually builds out an entire enterprise level environment in Azure, multi-subscription, multi-resource group, and actual like VNets and all this other good stuff, completely with leveraging Azure policy with deploy if not exist. So even kind of moving a little bit away from something say like blueprints, but controlling it through policy, which taps into ARM templates in this case, but a little bit, but still it's really interesting to see the flexibility that we've built into that.
Hey, Aiden, is that a 4-day workshop you mentioned, or do you have shorter versions, like let's say like a 2-day thing?
Yeah, so now we're going into the official Microsoft hat. But so originally, as it was explained to me, originally the Cloud Adoption Framework training was originally designed, I believe, to be, I think it was like 2 full in-person days, maybe 3 days perhaps in person, but obviously we can't do that now. And so we adjusted it to deliver to our partners officially through across 4 days. So we broke the sessions into like 2 or 3 hours per day. So it wasn't taking up like a full day, right? We just kind of make it a little bit more manageable from a time perspective because we're all remote now, right?
Okay, that's where I thought it's like 4 full days.
Yeah, no. I think it was like 2-3 hours a day in the afternoon that we each took a phase of the cloud adoption framework, and we did presentations and demos around the content. And personally, I specifically did the content on governance, cloud governance, and management. So, because I'm pretty deep in that space.
Oh, good to know. Thanks.
Yeah, but if there's anything like from that perspective, because that's more of an official Microsoft thing and not a user group thing, just circle back with your official company contacts in Microsoft around that, and you can name drop me when you do have that conversation, and then we can have a conversation inside Microsoft to figure out how we can support you.
Eddie, I have a question about marketplace appliances. I'm not sure if you have had any experience with deploying any third-party appliances or marketplace using Terraform.
Yes, some around like NVAs, right? Like the firewalls, right? Like Checkpoint or Cisco, right? Stuff like that. it can be a little complicated, right? Because it depends. It's not only just like a VM image and like high availability and stuff like that. Some of it depends on what they expose from that perspective, right? Like if you can tap into the image from a Terraform coding perspective, like a VM image to deploy it and make it in a availability set or availability zone, that's one bit, like multi-NIC, associating to the right subnet, all that good stuff. But then there's configuration, like even inside, which might not be quite as, dare I say, maybe accessible or exposed like a normal system would, that I've seen. So there's been some times where we've had to kind of work alongside with, say, Checkpoint, right, or the customer's on-prem networking or security teams on, okay, how is it configured on-prem, and then how do we kind of take that same config file or those at least applicable settings and map that into what we need to deploy and how it can be configured and deployed from a Terraform perspective. So yeah, not a whole lot of exposure, but that kind of gets a little complicated, and it's a little bit more subjective to what's exposed from the vendor perspective, right?
Right. Okay. So
yep. Go ahead.
So is I've seen some vendors provide like PowerShell scripts to deploy their the appliances. I'm not sure what Microsoft. I know you don't have the head right now, but do you think Microsoft will support like a situation where, or make it an option or maybe a requirement for third parties to provide also Terraform modules of code?
Yeah. Yeah, that's a hard one. Because now you're actually crossing three different companies, right? Because obviously there's Terraform from the HashiCorp perspective, right? To the creators of Terraform, and when they make changes or enhancements or whatever to the product itself, and then we as a Microsoft side, we're responsible for the Azure provider, so the Azure specifics of Terraform, right? And what is native in the provider to deploy. It's like, oh, Azure Firewall or this rule or this new feature or whatever, right? However, now you're kind of talking about third party. So even though it's in Azure, so it might be a question of not partly our responsibility because it's a resource object inside Azure, but then it's also a part responsibility of, like, say, the vendor, like Cisco or whoever, where it's like, well, aside from just deploying the VM, what other methods do they allow for, say, like inline script injection, right, and things like an execution? I'd have to kind of take that back to the Terraform team inside Microsoft to kind of get their opinion officially on that. I don't know, but maybe like shoot me a message on that just to remind me about that. And then if I get something official that I can share, I might write a quick little blog post on my blog to kind of answer that question for you.
Thank you, Edwin. Thank you.
Yeah, no problem. So there's a question about just getting the links to the repo. Yeah, so those are in the deck. Also, you can just hit up my GitHub profile and look under my public repos, and they'll be in there too. But they are in the deck. Yeah, we'll share those out when we get the recording up. And there's also a question about when we do post the recording, can we post the other links to the other ones in the series? Absolutely. We can definitely do that too. And I can maybe write a little blog post as well to kind of pull that together afterwards. So just to kind of get more visibility. Yep, not a problem.
Perfect. I think we are exactly at 2 hours now.
Yeah.
So, well, thanks very much, everyone, for staying through the entire presentation. Again, thanks, Aiden, for joining us and for a great content that you put together. And we hope to have you back in September or October with part 4.
That's right. September, I'm actually delivering this 3-part series for 2 separate user groups. So it'll be a little bit busy, but the Azure group takes priority because, you know, near and dear to my heart, because I was
that's where your heart is.
Way back when we started, right? So
exactly.
yeah, for sure. And definitely everyone, we'll share out when we get that form out Ezekiel, just getting people's opinions on kind of what else they want to see from a Terraform perspective. Really good idea. I like to kind of see what everyone wants as maybe as a follow-up or a part 4, or even just an independent Terraform presentation on something. I really like that idea.
Absolutely. So I'm going to stop the recording now. Perfect. Okay, and then we will share the slides and the recording via LinkedIn and Meetup.